Finish 6-4. I do want to review something that you might not remember. If you are taking a fraction, let's say 2/3, and you're multiplying by 3, do you remember what happens to the 3's? They cross off. If you have something in the denominator and something in a numerator that are the same, they can cancel out. So 2/3 times 3 is just going to be 2. So if I had 1/5 times 5, what's that going to be? 1. If I had, let me think, 3/4 times 4, what's that going to be? 3. Very good. Okay. What if I had something like 3/5 times 5/2? Then what do I have?
6.
The 5's cancel out, and I would have 3/2. Right? Multiplying tops, multiply bottoms. But if they cross off, okay. So if I had 1/6 times 6/7, what's that going to be?
1/7.
6's cross off, and that's 1/7. Okay. So since we're going to throw in that property of power to a power you multiply, that's something to recognize, and it's going to make it easier. Okay. So for example, I have 2/3 times -3. What happens to the 3's? They cancel, so I get -2. Can I have -2? No, that's got to go to the bottom and become positive.
Wait, why is it -2?
Because this is a negative times a positive, which is negative. Okay? So like this one, -4/7 times 7, what happens to the 7's? They cancel out, and I get x to the -4. Can I have x to the -4? No, you gotta put it on the bottom to become positive. Okay. So how about this one? If I have a -1, how do I make -1 positive? I put this, since this is in parentheses now, this whole thing is going to go to the bottom, right? And that now is a +1. But what's wrong with this answer? This 2/3 represents a radical. So now we're back, remember what we did yesterday, I can change that to a radical, cube root of x squared. How would I get rid of the cube root? I have 2 x's, I would need 1 more x. So the top becomes cube root x over 3x, right? Because now I have 3 x's, I can take 1 out. So notice this one, the 5's not in the parentheses, so the 5 can actually stay on top. But this x to the 2/3 is going to go on the bottom, so this -1 becomes a +1, right? But again, this is 5x over cube root of x squared. Can't have cube root of x squared, so I'd multiply by cube root of x. So I would get 5 cube root x over x, because now I have 3 x's, I can take 1 out. This property, if you have multiplying a times b to an x power, that x power is going to both the a and the b. Okay, that's one of the exponent properties. So if I have -27 times x to the -9, this 1/3 is going to go to both parts of that product. And this is where mental math comes in handy, because 1/3 we know is cube root. What's the cube root of -27? -3. Power to a power I multiply. So what's 1/3 of -9? -3, right? Or you can think of -9 divided by 3. What's wrong? Can't have that negative, so we put it on the bottom. So again, this 1/5 is going to go to both parts. Mental math, what's the 5th root of negative 32? Negative 2. What is 15 times 1/5? 15 divided by 5? 3. And I'm done. Okay. So again, 2 variables, but the -6 is just going to go to both. So what's 1/2 of -6? -3. What's -2/3 times -6? 4. Which one has to move? The -1. So this is going to be y to the 4th over x cubed. So again, this one, -12 is going to go to both, right? So mental math, or use your calculator if you don't like fractions. What's 2/3 of -12? 8, -8. What is -1/6 of -12? Multiply. Positive, because negative times negative is positive. Then I have to put that on the bottom, and I'm done. When you're doing division, to make this -1/4 is going to go to the top and bottom, right? That's one of our properties. If I have this to the x power, the x goes to the top and the x goes to the bottom. But in this case, I recognize, oh, there's same bases. So I would use my division of same bases to get this into one term, and then I can take power to a power. That's going to be easier than doing it separately. How did I get 4? 3 minus a -1 is 4. What's 4 times -1/4? Fix that. 1 over x. So that's going to be the same with this one here. These are same bases, so let's subtract. What's 2 minus -11? 13. Now I'm going to take 13 to the 1/3. So it would just be 13/3. Okay. But in this case, I'd want to keep going because you should kind of picture mental math. If I change that to a radical, there's going to be groups of 3 to come out. How many groups of 3? 4. Because 12, right? And then how many left over? 1. If you divide and they're not same bases, you can't subtract, and you just have to take the 12 to each one. So what's 1/4 times 12? 3. What's -3/4 times 12? -9, good. And then what happens to that -9? It's going to go on top to become positive. So then, again, not same basis, so you just have to take the 15 to both. So what's -2/3 of 15? -10, good. What's -1/3 of 15? -5. I'm going to have to flip both of these to become positive, right? The y is going to go on top, and the x is going to go on the bottom. Okay, so if you look at the next part of notes here, you should recognize that I have same bases. If I'm multiplying same bases, what do I do with the exponents? You add. So you can either add, hopefully in your head, or use a calculator, because we're going to take 2 7s plus 3 14ths, which is 7 14ths,
1/2.
which is 1/2. Okay? And I would be okay with that as an answer. If you wanted to make it into a radical, that's fine too. But since this is not going to simplify, you can leave it like that. Okay? You can always leave it as a rational exponent as long as the radical form doesn't simplify. Okay? Let's try another one. Okay, same basis, so I add what's 1/2 plus 3/10. 8/10, good, which would simplify to 4/5, and again, that's fine because radical form, 5th root of y to the 4th, that's not going to simplify. I don't have a group of 5, so it's done. So either one would be okay for an answer. Okay. When I'm dividing same bases, what do I do with the exponents? You subtract. What's 3/5 minus 3/10? Right, this would be 6/10. 6/10 minus 3/10 is 3/10. And again, that'd be fine because radical form, I can't simplify. So it's just done. Okay. What am I going to do? Subtract. What's 5/7 minus 3/14? 1/2, because it would be 7/14, which is 1/2. Very good. Okay. Now, when I'm dividing and I have more than one variable, you just take each base separately. Okay? So it's not any different. I'm still doing the same thing, but I just do the x's first, subtract, and then the y's subtract. So let's just look at the x's first. What's 2/3 minus 1/2? It'd be what? 4/6 minus 3/6, which is 1/6. 4/6 minus 3/6 is 1/6. Okay. Now, what's negative 1/4 minus a negative 1/2? Right. This would become 2/4 negative. So what's negative 1 minus a negative 2? Negative 1 minus a negative 2 is 1. So it'd be 1/4.
I got that right.
Jeez, guys, catch up.
And you can leave it like this because the radicals wouldn't simplify, and it's on top, not bottom, so that's fine. Okay, and you could do this, but either one is fine because they don't simplify. Okay. Let's try another one. So what's 1/2 minus 3/4? Negative 1/4. Good.
How do you do that in your head so fast?
2/4 minus 3/4. Negative quarter. Right?
I don't have that ability.
Negative 1/3 minus half. So that would be a 1/6, right?
Yeah.
So it would be negative 2/6, and this would be 3/6. So what's negative 2 minus 3? Negative 5/6. Okay. Now I can't be done here because in this situation I got negative exponents. All right. So we have to put them on the bottom. Change them to radical form because you can't have rational exponents on the bottom. So I would have 4th root of x, 6th root of y to the 5th, and I'm going to rationalize the denominator for both of them. So let's just do the x first. If I have 1x and I'm doing 4th root, how many more x's am I going to need? If I have a 6th root and I have 5 y's, how many more y's do I need? 1. If I do it to the bottom, you have to do it to the top. 1 times anything is that, so that's easy, right? It'd just be 4th root, 6th root. Now, why did I do this? Because now I have 4 x's, I can take 1 out. I have 6 y's, I can take 1 out. And now it's simplified. Okay, so you should recognize this is a square root, right? 1/2 power square root. And hopefully you also recognize that 16 and 81 are perfect squares. Okay, that square root, or 1/2, is going to go to both of those and both of these. So I can say, what's the square root of 16? 4. What's 14 times half? 7. What's the square root of 81? 9. What's 18 times half? 9. See how that works? You're using two properties there. You're using the product property where that's going to both, and then you're using the quotient property where that goes to top and bottom. Okay, let's try another one.
What are they listening to?
So again, you should recognize half as a square root. Half is going to go to everything. So what's square root of 81?
9.
What's half of 16?
8.
What's square root of 16?
4.
What's half of 12?
6.
Good. Okay, so they look really complicated, but when you start just picking it apart with your properties, it simplifies everything.
I'm gonna be watching this video a lot.
One more. This is cube root. You should recognize now that 1/3 is cube root. And you should recognize 8 and 27 as cubes. What is the cube root of 8?
2.
What is 1/3 of 6?
2.
2. What is the cube root of 27? What is 9 times 1/3?
3.
There you go. You're done.